Welcome back to All This Math, and today's video is dedicated to Fannie Lou Hamer, the late Fannie Lou Hamer, who was a native of Mississippi. I believe she was born in Rouville. I might be mistaken, but she definitely was a resident and a native of Mississippi. And I also want to give a shout out to the Ashe Academy. The Ashe Academy, which is a small school located in Coldwater, Mississippi. I want to shout out Sister Crystal, Brother Patrick, and forgive me, all the other people that are involved with that small school, educating those young people the way they need to be educated. I don't know everybody's name, but I definitely want to shout out those two whose names I do know. I hope the young people are able to watch this video on dividing fractions and, be reminded of people like Fannie Lou Hamer, who's from Mississippi, just like them. Of course, Fannie Lou Hamer was involved with the Student Nonviolent Coordinating Committee. She was very instrumental helping out with the work of people, other members of the Student Nonviolent Coordinating Committee, people like Kwame Ture, people like Charles Cobb, people like Cleveland Sellers, people like Marimba Ani, people like Bob Moses, and the list goes on. There's so many names that, I can't really name all of them right now. This video will go on for forever, for a long time, much longer time. But I do want to definitely shout out and recognize this ancestor, Fannie Lou Hamer, because I don't think she's recognized enough. So I would like to recognize her. Since I have this t-shirt on, this Fannie Lou Hamer t-shirt on, so I might as well. Why not? I mean, it's my YouTube channel. Why not? People need to know about her. So if people need to know about people, you gotta mention their names. You gotta say their names, all right, to take them out of obscurity. So with that being said, let's get into the math now. So we have this division problem. We see the division sign, so we know it's a division problem. We have -5/6 divided by 2/3. -5/6 divided by 2/3. So what that essentially means is we're trying to find out how many groups of 2/3 can fit into -5/6. How many groups of 2/3 can fit into -5/6? Now, since I want you to think about this. Since I know that 2/3 as a fraction is smaller than 5/6, right? And notice I didn't say negative, right? Because in terms of, for this step in the process, I'm kind of disregarding the negative sign. So I'm not really worried about the negative sign right now, right? For this part of the process. So how many 2/3 can fit into 5/6? I know that an entire 2/3 can fit inside 5/6 and a part of another 2/3 at the same time, because 2/3 is less than 5/6. Now, how do I know that? I'm gonna tell you a trick that I use. I'm gonna tell you why I know that. One of the ways you can know that too is knowing the decimal equivalents of fractions. So if you learn the decimal equivalents of fractions, just like you should learn your multiplication facts, at a minimum from 1 times 1 all the way up to 12 times 12, right? If you think about the multiplication table in the back of a composition notebook, memorizing all those numbers inside that grid, you should also think about learning your decimal equivalents to fractions. So I know that the equivalent of 2/3 is 0.67, or we can think of it as money, 67 cents. 2/3 of $1 is 67 cents. I also know that 5/6 is the equivalent of 0.83, or it's 83 cents. Now, the only reason I know that is because I made the effort to try to memorize those numbers, because I knew I was going to see them a whole lot, right? In terms of being a math teacher and a math professor, I knew I was going to see those numbers a whole lot. So I said, I might as well just memorize these. So my suggestion to you is, early in life, much earlier than when I did it, I suggest that you memorize the decimal equivalents of, frequently seen fractions also. So 2/3 is 0.67, 5/6 is 0.83, right? Because 2 divided by 3 is 0.67 and 5 divided by 6 is 0.83. So that's like, in terms of money, like I said, that's like 67 cents and 83 cents. We know that 67 cents is less than 83 cents. So this whole 67 cents can fit into 83 cents with some left over. So then that would be another 16 cents. So that would be like a piece of another 67 cents. Not a whole other 67 cents, but a piece of another 67 cents. All right? Because that's what we're doing with dividing. When we're dividing, this is called our dividend, right? The first number is called our dividend. The second number is called our divisor. What we're trying to figure out is how many of the divisor can fit into the dividend, or how many of the second number can fit into the first number. Again, how many of the second number can fit into the first number? So we know that the whole second number and a part of it and another part of it could fit into the first number. So that gives me an idea of what my final answer is gonna look like. So check this out. Let's use our keep, change, flip method. Keep, change, flip method to just do this division. So we're gonna keep the negative 5, 6 as our first fraction. We're gonna change the division sign to a multiplication sign. We're gonna change our division sign to a multiplication sign. All right, I'm gonna use a dot for multiplication. You can use a dot or an X, whatever you prefer. Those are the most popular symbols to use to represent multiplication. And then we flip the 2/3. So when we flip the 2/3, that means we're taking the reciprocal of 2/3. So that means the 3 goes to the top and the 2 goes to the bottom. So that becomes 3 halves. So now I'm ready to multiply. But look, I got a 6 and a 3 that are diagonal from each other. So I like when that happens. You know why I like when that happens? Because when that happens, that means I can do something called cross cancel. Cross cancel. Meaning I can reduce those two numbers before I even multiply. Now, what that means is because 3 and 6 have a common factor. What's a common factor? A number that they share that can multiply into both of them. Both of them, right? 3 can multiply into 3 and 3 can multiply into 6, right? And because of that, I can divide both of those numbers by 3 and create a smaller number, all right? So since 3 can multiply into 3, I can do 3 divided by 3. So that 3 turns into a 1 because 3 divided by 3 is 1. 3 can go into 6 or multiply into 6. So that means I can do 6 divided by 3. And 6 divided by 3, because I know my division facts, because I know my multiplication facts, 6 divided by 3 is 2. And I just cross cancel. By cross canceling, I make some of my numbers smaller, so then that makes my multiplication easier. So cross canceling is a method that you can try. You don't have to do it, but you might want to do it because it makes the math easier. All right. So now we have negative 5 times 1, which is going to be, well, actually, I'm going to just write the negative sign because I know my answer is going to be negative. My quotient is going to be negative, or my product, because I'm doing multiplication. But remember, the original problem was a division problem. So actually, my answer is technically a quotient, even though I'm doing multiplication in this part of the problem. So my quotient is going to be negative because whenever we have a negative and a positive, the quotient is always going to be negative. All right? If the signs were the same, the answer would be positive. But the signs are different. This is negative and this is positive. And how do I know that this is positive? Because there's no negative sign. You don't have to write a positive sign. You could if you wanted to, but there's no need for that. All right? So 5 times 1 is 5. 2 times 2 is 4. And we have negative 5/4. Now, here's the next question. How do I know if I'm done? Because with fractions, you always want to reduce fractions. You always want to simplify fractions whenever possible. The reason I know I'm done is because if I look at this 5 and this 4, or this numerator and this denominator, the only common factor they have is 1. Meaning, the only number that can multiply into each of these numbers evenly is a 1. 2 can multiply into 4, but 2 can't multiply evenly into 5. You would have a remainder, or it would be a decimal. 5 can multiply into 5, but 5 can't multiply evenly into 4. 5 is bigger than 4, so that can't work. So the only common factor that 5 and 4 has is 1. Whenever you get in that situation, that's how you know you're done, because you can't reduce. When your greatest common factor is a 1, that's how you know you're done, because you can't reduce it. So this is your final answer. Box him up. Negative 5/4. Now, negative 5/4 is also equivalent to negative 1 and 1/4, because 4 goes into 5 one time, with 1 left over, because 5 minus 4 is 1, and you keep the same denominator, so negative 1 and 1/4. Now, I knew that was going to be, I was going to get this type of answer because from the beginning, I know that 2/3 is less than 5/6. So I know that a whole 2/3 can fit into 5/6. That's where this 1 comes from, right? And I know a portion of the 2/3 can also fit into 5/6. because it's more of it left. It's more space left, basically. Think of it like that. It's more space left because 2/3 is less than 5/6, so it's more space for part of another 2/3 to also fit into 5/6. That's where the 1/4 comes into play. So 1 and 1/4. So that's how many 2/3 can fit into 5/6. 1 and 1/4. All right. So I know that's a lot to think about, but that's cool. The way you really learn math is through practice. All right. I showed you how to do one of these problems. Now, the way you really learn it is to go practice on your own, in your own time, and on a daily and a regular basis. Right. So you get repetition and you develop what we call muscle memory. All right. So as I said, if you're not as familiar with Fannie Lou Hamer, please go do your research. There are books that have been written about her. I don't think she had an autobiography, but she may have. I may be mistaken. She may have an autobiography that I'm just unaware of. But there definitely is a lot of biographical information about Fannie Lou Hamer. Please go check her out. Learn about the history of the work that she did in Mississippi and beyond, and the community that she was a part of, if you're not already familiar. And as always, go get some practice. Peace.